Before we start, I just need to point out quickly that as per the title of our paper, there will be some small bits of flickering on different parts of the screen throughout this video. With that out the way, hi, I'm Jonathan, and it's my privilege to present to you our paper, Flicker Augmentations, Rapid Brightness Modulation for Real-World Visual Guidance Using Augmented Reality. This work is a collaboration between myself, Tobias Langlotz, of the University of Otago, Alexander Plopski, who's now at Graz, and Kasper Hornbæk from the University of Copenhagen, and I'm currently at the University of Copenhagen. So why are we looking at flicker in augmented reality? Well, augmented reality glasses are expected to become items that we use every day in our daily lives to help us to complete daily tasks. And one of the ways that they can do this is helping us by visually guiding us when we're looking to complete search tasks, such as looking for where we parked our car. Traditionally, this has been achieved using virtual artifacts from augmented reality, such as arrows, or by placing outlines around things. And this has been extensively researched for many years now, with people looking at various ways to apply these different kinds of guidance in different situations. And it's been shown that, well, they work. However, there are some concerns with using them. They do introduce extra artifacts into the scene. These can include the surrounding information, and it's known with generally when in augmented reality, when introducing virtual artifacts that are associated with the task, we tend to tunnel our attention on them, which can cause us to miss other parts of the scene. Introducing extra artifacts is also considered to be an issue for increasing the amount of clutter in a scene, particularly if we're already introducing other virtual artifacts for labels and that kind of stuff. And there are also questions about the accuracy of arrows and being able to interpret where exactly they are pointing to and what they mean. So researchers have looked at other approaches to providing visual guidance. One of these recently has been to use visual saliency to direct your attention. Visual saliency is the properties of an object that make it stand out to you in the world. Say this has previously been researched more recently, looking at how more subtle effects can be achieved to also provide guidance to certain areas in a scene. However, these approaches also come with their drawbacks. They typically require very precise modulations to actually tweak to a pixel level what you're seeing, the saliency of the object. They're often very context and user specific in their tuning and parameterization, and they can be very dependent on the scene content, as well as most current approaches for AR glasses require customized hardware and are very complex to set up. And so finally, in traditional screen-based interfaces, people have also looked at using temporal effects such as flicker to be able to draw people's attention to certain areas in the scene. And so this has been explored in various different screen-based applications, where sharp bursts of flicker are used to draw you and help you in search and imaging. However, they haven't currently been investigated in augmented reality glasses, where your light control is typically limited and you're constrained to what you can introduce into the world that already exists around you. You also have unknown viewpoints, users are moving around, and the other area where related research is lacking is that there are limited comparisons between flicker and the alternative techniques, particularly between saliency and flicker. And so the first thing we wanted to answer was, why use flicker? We have these alternative approaches, and as discussed, despite drawbacks, they are known to work. So to this end, we looked to create a user study where we actually compared flicker against the different techniques. All the different techniques we implemented were drawn from previous work, where we compared against no guidance. We used flicker-based guidance, we used a circular outline-based guidance, and a saliency modulation technique. So you can see these here, but we also looked to apply them at different overtness levels to make them stand out a bit more or less, as this is something that's commonly done, at least for saliency, is the subtlety effects. So full details in the paper on how we went about doing all that. So for this user study, we had an apparatus where an image to be shown to the user was displayed on the screen, so an image where something wanted to be guided to, and then we had some optical AR glasses seated in front of the display, so that's what you're seeing at 2 there, and on that we projected the overlay that would be used to modulate the world, so in this case the outline, and behind that we had a camera and that camera was seeing through the optical see-through head-mounted display, the AR glasses. It was seeing the overlay combined with the real world, and that was capturing the overlaid image to show the effect. And then we took that image and we displayed that in virtual reality. And so we didn't actually do this live. We pre-took a whole set of images. There was 80 different test images that we used in total, and then we displayed these in a VR scene. And by doing this, we were able to create a very highly constrained test environment where we can ensure that all the users were seeing exactly the same image material, which can be a problem with AR glasses where you have calibrations that need to be precise, particularly for the saliency modulation, as I said. It also gave us constrained eye tracking setups and a controlled environment where we can set them into a dark room, make sure they're always facing the screen, that kind of stuff. And so the participants were shown an effect a bit like this, where they were shown a centering point, and they were shown the image for a few seconds, and it was taken away, and they're asked how overt the modifications to the image were, and that just cycled through the different test conditions. And then we ran a within participants study where we had 28 participants. Each participant looked at 5 images per condition, and we looked at different variables such as the time to find the target, the typical effectiveness measure for guidance techniques. We also looked at the area of the image they explored. We looked at how much they considered the overtness of the techniques, the perceived overtness, as well as asked them some open questions. And so looking at some of the highlights of our results for the time to fixation, so how quickly they looked at the target, we saw that once there was an initial guidance, once the overtness of the flicker got above a certain threshold, it was actually the quickest technique, followed by geometrical, and saliency didn't tend to get above a certain point where it wasn't any more effective. Looking at the area that the people explored the images, how much they carried on looking around, even if they'd found the search area, we found that flicker tended to hold their gaze at the target area the most, whereas geometric actually still allowed them to look around a bit more, and then saliency, which drew the target the slowest, also had the most area of the images explored. And again, see the paper for the full discussion, but some of the takeaways, or the important ones, was that flicker worked once you had an initial high flicker to draw the attention, so this is in line with the related work, and it was, however, considered to be overt, and there was no need to keep the constant flicker there, so regulation was needed to bring that back down and control it. We also saw that the saliency method that we used was less effective at drawing gaze than the other two approaches. And so, having looked into why you might want to use flicker, what its advantages were and its disadvantages, the big question to answer next was, how does it actually apply in practice? Some of the restrictions on the previous work that we discussed were still shown in our previous study, and so we wanted to look at how does it happen if we take it into a more ecologically valid scenario. So the previous study was focused on the precise impacts across a number of study conditions, and in this case we were looking at just the flicker when it was displayed directly with users actually wearing an HMD, where you have a limited field of view, they're able to move around, free viewing angle and time, so no constraints around that. And we also want to see what happens when they have a task, when you're actually doing something with flicker applied. So to this end, we created a task where the users had to turn around and find a tool on the table and then turn back to the monitor that they had been facing. So this was to emulate the idea of somebody deciding they needed a tool based on what they were doing, turning around, finding that tool, and then going back to what they were doing. And again, we had conditions where we looked at no guidance, if they had that constant flicker, and then we wanted to see, well, once we introduced the gaze modulation, how does it affect it? With it just a limited, simple turning it off when people had actually looked at it, so nothing complicated, just if we do something simple and implementable, and also what happens if we don't do anything when we're in an actual task environment. So the actual study runs a bit like this, where a user turns around, they look at the tool, it flickers for them. And if you've ever tried to take videos through HMDs, you know, it's good fun, particularly with things like the HoloLenses. But anyway, and so that's all they had to do with the study. And then when they turned around, they're given some questions to answer, some lickets. And at the end of the study, they also had some more open-ended questions to answer. So yeah, as I say, we did it within participants design, 24 participants this time, and each time they had to find 12 tools, so 4 per condition. And again, we were looking at time to find the target, time to complete the task, perception of the guidance, and as I say, open questions at the end. The results, the high level, we were able to replicate our results in terms of time to fixation when we came to a practical task. So yeah, our results replicated into a more generalized scenario. We did also notice that participants tended to take the time to face the table or look at the tool a bit before they turned around, and again to actually end the task when they had turned back to the thing. So we looked to the monitor. So we looked at how long they spent facing towards the table. Details on that are in the paper. And what we noted was that only the constant flicker caused them to turn back quicker, and when the gaze modulated flicker, they were actually facing the table for a not significantly shorter amount of time. And the overall task time was not actually decreased at all. And so again, takeaways from our paper with full details in the paper, but high level were that flicker worked in the practical scenario, that using simple gaze modulation improved comfort over the unmodulated constant flicker, as one might expect, but we also noted surprisingly that it increased comfort over or somewhat surprisingly, over the unmodulated condition where participants felt more comfortable completing the task in an unknown scenario where they were given the added benefit of the guidance. We also noticed, though, that participants noted that flicker could occlude the targets. They weren't necessarily able to see what they're looking at, they were just looking at the flicker. And participants relied on the guidance, noting that they were just looking for the guidance rather than actually looking for the tool that they were told to look for. And finally, we noted that, as we see, the overall task time wasn't actually adapted or wasn't significantly affected to a degree that was worth mentioning. And so we would point that looking at things like usability rather than the effectiveness of guidance is potentially a way to go forward looking at these techniques. So to summarize the paper, we demonstrated the use of flicker in augmented reality glasses and contributed to the wider understanding of augmented reality-based guidance. We did this via 2 user studies, the first being the controlled study, where we looked at compared different techniques and why you might want to use flicker, and the second, the more ecologically valid study, where we looked at the impacts in a practical task. We saw that flicker is a more effective means of guidance than the current approaches, however the regulation on the effect is needed, and that how we look into these techniques in wider practical tasks might need change. And finally, we noted some general issues for guidance and the reliance on it. So with that, thank you for your time, and please see the paper if you want to see the full details, discussions, and findings.